Hi, in this video we are going to look at a particle in equilibrium, but when there is an influence of friction. So we are seeing that a block of mass 3 kg rests on a rough horizontal plane. Now this word rough means friction exists, and the coefficient of friction between the block and the plane is 0.4. So you need to note that friction force is given by coefficient of friction times the normal reaction, and the normal reaction is always given by mass times g, because it balances the weight if at all it is on the horizontal plane, as we are going to see. So now when the horizontal force P is applied to the block remains in equilibrium. Now the block remains in equilibrium simply because of friction. So we have a limiting equilibrium. So let us try to illustrate. So if this is the rough surface, and we have our block. Now the mass of this block is 3 kg, meaning there is a weight acting downward. Then this weight will be balanced by the normal reaction. The surface, this ground, will provide a normal reaction. So if the mass is 3 kg, it means the weight, which is equal to mg, is going to be 3 g then newtons. And now we have the normal reaction. Now here the two forces are balancing, so the normal reaction balances the weight. Alright, let us see. Now the coefficient of friction between the block and the plane is 0.4, so the coefficient is 0.4. Now we have a horizontal force P, which is applied to the block. Now there is a force, assuming that this force is in this direction, so it tries to pull the particle. This is P newtons, trying to pull the particle to the right. Now the friction force between the surface and the block will try to oppose, so we shall have that friction force given by mu r, which will oppose. Now if the body is in equilibrium, that means it is not going to the right and it is not remaining going to the left, so it is remaining in one position. That means that this horizontal force and the friction force are equal. So let us apply the necessary equations. So we have horizontally P will be balanced by the friction force. So our P is going to be, friction is given by coefficient of friction times the normal reaction. That is equation 1. Then vertically, this block is going to be balanced by the so the weight of the block is going to be balanced by the normal reaction. So R is going to be equal to mg, which is 3 g newtons. So if we need to find the value of P for which the equilibrium is limiting, that is the maximum friction force. At limiting equilibrium, friction force is equal to mu r. So let us see what we get from these two equations. So part A, the value of P for which the equilibrium is limiting. We have said that at limiting equilibrium, because we know that always friction is less or equal to mu r, and at limiting equilibrium the friction force is going to be equal to mu r. That is the maximum friction force we shall get. That is when the block is at a point of moving but not moving. So let us see. From this equation you can find mu R, which is equal to P. So P will be equal to mu is 0.4 and R is equal to the weight, which is equal to 3G. So our P is going to be equal to, so we get 11.77 newtons. So that is when that is the value of P, which is the equilibrium, when the equilibrium is limiting. So we have the maximum friction force. Now part B, we are told to find the friction force when P is 80. Now we are going to have the same weight of the body, so same friction, because mu is going to remain the same. But now we shall see that now the force is reduced. When the force is reduced to 80 newtons, what is the value of F? Okay, so P is 80 newtons. So now equilibrium is going to be maintained, because when the force was like 11.77 newton, we were in equilibrium, the body was not moving. But now when we reduce the force, the equilibrium is going to be maintained, because this force is now less than the initial one. So which means that we are going to still have friction force, no, P minus friction force, we shall get 0. We cannot have any motion, so P will be equal to F. So our F is going to be equal to 8. But this is when you have friction force less than mu R. The maximum friction force will occur when F is equal to mu R, but friction force will be equal to mu R, because mu R is 11.77. So, but it is not limiting. It is still less than mu R. So when it is equal to mu R, that is when you have limiting friction force. So again, if the force is 80 newtons, the friction force will be 80 newtons, because the maximum is going to be 11.77, which is the limiting, the one which when the particle is at the point of moving. Hope that is clear, and I hope this video is helpful. So always understand this statement: limiting equilibrium, that is when you have maximum friction force acting on a body. Yes, because we always have friction force less or equal to mu R. So the maximum is when friction force is equal to mu R. Okay.